Hi everyone, in this demo I'll show you how increasing the separation between two clusters impacts the performance of a logistic regression model. We'll analyze how shifting the clusters changes the decision boundaries and key model parameters. For this experiment, we set the shift range between 1.5 and 3.0 with 8 steps. This means we gradually increase the separation between the two clusters across 8 intervals. Let's explore the results. So I'm going to press run experiment. And here are the results. So based on the scatter plots, we can see that as the shift distance increases, initially when the clusters are closer together, the logistic regression model struggles to confidently separate the two classes. This is evident from the wider margin and overlapping regions in the scatter plots. As the clusters start to separate, the decision boundary becomes more stable and the margin width decreases, indicating increased confidence in classification. However, after a certain point, when the clusters are very well separated, the margin width increases slightly. This indicates that while the model has clear separation, it's optimizing the confidence interval to accommodate fully distinct clusters. Now let's look at the summary plots to understand how the logistic regression parameters and metrics change with increasing shift. So for the model coefficients, beta 1 and beta 2, they adjust as the clusters move apart, reflecting the changing shape of the decision boundary. As the clusters become more separated, though, these coefficients stabilize, indicating that the model is finding an optimal separation line. As for the slope of the decision boundary, the slope stabilizes as the shift increases, which shows that the decision boundary becomes more consistent with clear separability. Now for the logistic loss model, where is it? Oh, I'm zooming in. The logistic loss decreases significantly as the clusters separate, indicating that the model's accuracy improves. This is because there's less overlap between the classes, reducing classification errors. And finally, for the margin width, it initially decreases, showing increased confidence in the model's classification as the clusters separate, but interestingly, after the clusters are fully separated, the margin width slightly increases, and this indicates that the model maintains a margin for classification even when the separation is optimal. So in summary, as the clusters become more distinct, the logistic regression model becomes more confident, as shown by the decrease in logistic loss and adjustments in coefficients. The decision boundary becomes more stable, with the slope and intercept ratio stabilizing as well, and the margin width decreases initially, but slightly increases at the end, showing that the model optimizes its classification margin even when the clusters are fully separated. So overall, this project highlights how logistic regression adapts to changes in data distribution, providing valuable insights into how classification models work. Thank you.